My dear friends, welcome to Rajashekar classes on applied data science with Python. This is lecture number 415. In this lecture, we will try to understand extremely randomized trees. So, there is a variation of random forest called extremely randomized trees. They become very popular because scikit-learn actually implements something called extreme extra tree classifier and extra tree regressor. Just say this one, extra tree classifier and extra tree regressor, which automatically implements extremely randomized trees. It is very simple. You should import extra tree classifier. Just from sklearn dot ensemble import extra tree classifier, and you just use it like there is a certain difference between extremely randomized tree and random forest. In random forest, what do? We perform column sampling, we do row sampling, of course, we do aggregation, isn't it? Which is this is about random forest. What extremely randomized trees? We call it as extreme trees for now. Extreme trees goes one step further. It adds one more level of randomization, isn't it? It adds, just check this one, it adds one more level of randomization, isn't it? What they do here is extreme trees does something very interesting. What it does here is, let's assume I am building one of my base model mi. Let me say I am building a base model mi. While building these base models, I am at some level of the decision tree. Just let me assume this is some level of the decision tree. Let me assume we are at some level of decision tree, isn't it? At this stage, we are at this stage. Let it be, isn't it? I am trying to determine if feature I, fi means what? Fi means feature I. If feature I, suppose, let's assume feature I, fi, is real valued feature. What is this? This is real valued feature. We already discussed about real valued features and threshold values. If a feature I is a real valued feature, now I am seeing if I can set up a threshold on feature I. Let me say if I set up a threshold on feature I and saying yes or no. So to compute this threshold, what do we do in regular decision trees which are used in random forest? Random forest uses your regular decision trees, isn't it? What do we do? What we do here is in decision tree or random forest, because random forest is simply use regular decision trees. Just try to recall, we discussed this one. We first sort all the values, isn't it? First, what is the procedure? We first sort all the values of fi, isn't it? We first sort all the values of fi. Just say these are the values of fi. Let me assume these are the values of my fi. For each value, suppose this is 1, 2, 2.2. Let me say these are the values 1, 2, 2.2, 3, 4, and 6. Isn't it? Now we try to check for each value of this as a threshold value. I will check whether it is threshold value, whether it is this threshold value, all this, isn't it? What we do, we try to check for each values of this as threshold. We are checking each value of this as threshold value. We learned this when we learned on how to handle real valued features. I already discussed how to handle real valued features in our my previous lecture. Just go through that, isn't it? I will pick that value. Which value I can pick? I will pick that value which gives me maximum Gini impurity, the maximum information gain or maximum reduction in impurity. In regular decision trees or random forest, I try out all the possible values of Fi. Just, isn't it? In regular decision tree, what is the procedure? We try out all possible values of Fi. That is the case with regular decision trees. This is important. We will try out all possible values of that particular feature to determine appropriate threshold, isn't it? I try all the possible values of Fi to determine appropriate threshold. This is what I do. Isn't it? In extremely randomized trees, or simply says, instead of trying, this point is important, instead of trying out all possible values, because there are n possible values, if my training data set has n data points, there are n such values. Instead of trying out all of them, what I try out a random sample of possible values. Here what can I do? I will take a random sample of possible values of Fi. Random sample of Fi to determine threshold value. Here it's not. We try all possible. Here we are considering in the case of regular decision tree or random forest, we try out all possible values, whereas in the case of extremely randomized trees, we consider random sample of possible values of feature I to determine threshold value. This is the core idea. This is a core idea. This is core part of extremely randomized trees. If I try this possibility, if I take all possible values, I would try every possible value of that threshold, which is very time consuming. Problem with this approach is, which is time consuming. This is time consuming, isn't it? Which is very time. Instead of this, if we take bunch of random sample of possible value, means what? We take, instead of this, we take a bunch of values, not all values. We take bunch of values, isn't it? Pick, let me say, pick 10 random values. Let me say, pick 10 random values of feature I. 10 random values of feature I. Check out these 10 random values. Pick the best value. Out of these 10 random values, we will try to pick best value, isn't it? Best value among these 10 values. We are not running away from picking of best value, but instead of finding all values, we will do one subset or random sample of possible values. Here again, we are using randomization. What happens in extreme trees or extremely randomized trees? Extreme trees, what is this? Extreme trees have just, let me say like this. Yes, extreme trees have just like column sampling, isn't it? Here in this case, we are trying all possible values. That's what I'm saying here. Just see, here we are checking all possible values, all possible values, isn't it? What is this? Extreme trees. Extreme trees have just like column sampling, it has row sampling, it has aggregation, isn't it? It has aggregation. In addition to it, it has randomization. This is columns, it has column sampling, row sampling, in addition aggregation. This is randomization when selecting threshold. This point is important. In just decision trees or random forest, we are checking all possible values. For example, here we are trying out all possible values. Just let me say, yes, all possible values. Here we are doing all possible values, but random sample of possible values here means this. That's what it says. In the case of extreme trees, in the case of extreme trees, column sampling, row sampling. This is common for decision trees, isn't it? But extra thing is this one. This is extra randomization when selecting threshold. In addition to it, it has randomization when selecting threshold, especially for real valued features, isn't it? Yes, this I can say randomization. What is this row sample? This is a new which one is randomization? Is way to reduce variance, isn't it? Why we are keeping randomization? Randomization is a way to reduce variance. Remember, in the case of random forest, we used randomization in the form of column sampling, row sampling. Here we are using randomization in the case of random forest, isn't it? In the case of extreme trees, this is extreme trees. In the case of extreme trees, we are using column sampling, we are using row sampling, randomization in selecting threshold. Here in random forest, we have two types of randomization. Just see, in random forest, one type of randomization is column sampling, another one is row sampling, isn't it? In extreme trees, in addition to this column sampling or row sampling, I have additional form of randomization, isn't it? Again, randomization is a way to reduce variance. So extreme trees tends to reduce variance better than random forest, but of course bias might slightly increase. Extreme trees are small variations of random forest which are very useful, especially when you have real valued features, especially when computing threshold. By adding one more level of randomization, you are going to reduce variance slightly better than random forest. Frankly speaking, I have never used extreme trees in my own professional experience, but I have read about research papers, but I have not used, since it is implemented and it is implemented and readily available in scikit-learn. We could try this extreme extra tree classifier. Just go through this. If you have any difficulty, please keep a comment. Thank you very much.